Hey guys, welcome to video number 3 on vectors. This is the last video that we're going to have about vectors. So far we've talked about a lot of different things. We've talked about the component form of vectors, where the initial point is right at the origin, right at 0, 0. And from that we started to talk about how you can find the magnitude of the vector, that's the length or the size. And we found that you could do that using the distance formula, which is shown right here. And you can also do that using the Pythagorean theorem. Today, we're going to use trigonometry to find the direction of a vector. So we're going to find the angle measure that the vector is. Now, back in the first video, we talked about how you can describe the direction of a vector in multiple different ways. You can say it is so many degrees west of north, or it's this many degrees from the horizontal. We're going to simplify things in video number 3 when we talk about finding the direction of a vector. We are only going to talk about it in terms of the number of degrees from the horizontal. So we are not going to use any directional verbiage here. We're not going to use north, south, east, and west anymore when we talk about direction. We're just going to take a look at where the vector is on the coordinate plane, and we're going to say that vector makes an angle of whatever it is. In this case, in this example here, 231.3 degrees from that kind of initial starting point. So imagine all vectors are going to start right here, and then the vectors are sometimes going to be scooched maybe 45 degrees that way, or maybe the vectors are going to be scooched 180 degrees, in which case they would look like this. Or maybe the vectors are going to be 120 degrees, so then they would look something like, let's see, 90, 120, something like that. So when we talk about directions for vectors, we're going to assume that the 0 degrees is this one that I'm highlighting right now. That's 0 degrees. And so every other angle, we're going to say it's this many degrees, it's this many degrees. And what we mean by that is we mean it's this many degrees away from that initial kind of starting line right there. So let's talk about how we can figure out what the direction of a vector is. Let's take a look at this example that's on the screen right now, and let's see how they found the direction of this vector. That's their example problem. When they were trying to find the direction of this vector, they actually started by trying to find angle theta, which is this angle right here that I'm circling. And after they found out what that angle was, they added it to 180 degrees. So how did they find out what the measure of angle theta was? Well, they looked at the graph and they were like, hey, my vector, vector r, can actually form a right triangle if I draw in some dotted lines. So they drew in this line right here, and they knew that this line had a length of 4 because their vector was plotted at -4, -5. And then they drew in another line here and they said, okay, the length of that is 5. And so this whole part over here formed a right triangle. And so what do we know about right triangles? Well, we know a squared plus b squared is c squared. We know that we can use sine, cosine, and tangent with right triangles. So they used tangent because if they're trying to find this angle theta here, 5 is the opposite side, 4 is the adjacent side. So they set up their problem by saying the tangent of this angle is 5 over 4. Tangent is opposite over adjacent. And then they solved it to find the measure of the angle by taking the inverse tangent of both sides. When they did that, they put in their calculator inverse tangent of 5/4, and they got 51.3 degrees. Now that wasn't their final answer, because 51.3 degrees, that was angle theta. They had to add it to 180 to get that entire angle from here all the way to here. So they added 180 plus 51.3, and they got 231.3 degrees. That's the final answer. That is the direction of this vector. that's basically it for today. We're going to do a couple example problems. I'm going to walk you through maybe one or two more together, and then I'm going to ask you guys to try some on your own. But that's it. The only goal that we have for today is what we just did, finding the direction of a vector. So let's go ahead and take a look at the first example problem together. All right, so we've got our first vector here. This vector is 2, -4. So this vector is in its component form, and we are trying to find the direction of this vector. I'm going to make a quick little sketch over here because I'm a visual learner, so it's going to help me to kind of see what this vector is going to look like. 2, -4 is going to be over 2 and down by 4. So this is where the final tip of the vector is. So this is what my vector is going to look like. Now, anytime a vector is in the third or fourth quadrant, this is the third quadrant and this is the fourth quadrant, the direction of the vector is always going to go this way. So the degree is going to be a very, very large degree, a large angle measurement. We're never going to use this tiny little one right in here. We're always going to go all the way around like this. So we're trying to find the direction of this vector, but in order to do that, I'm going to draw my right triangle here. So I'm going to zoom in here, and I'm going to draw this little right triangle, and I'm going to label this side as 4 units long because I went down by 4. This side is 2 units long because I went over by 2. And I'm trying to find which angle am I trying to find? Is it going to be angle X right here, or is it going to be angle Y right here? Which one do I need to find? I need to find angle Y because angle Y is this angle right here, and altogether I'm looking for this inside angle. So I'm going to try to find angle Y. Once I find angle Y, then I'm going to add that to 90 plus 90 plus 90 to 270. So first I find angle Y, then I add it to 270 to get my answer. So how do I find angle Y? Well, it's a part of a right triangle, so I can use sine, cosine, or tangent. Here I have the opposite side is 2, and the adjacent side is 4. So I'm going to say that the tangent of angle Y is opposite over adjacent, so it's 2 over 4, or 1/2. In my calculator, I type in inverse tangent of 2/4 because we're taking the inverse tangent of both sides. And I find that the inverse tangent of 1/2 is 26.6 degrees. And then remember, we have to add this to 270 to get our final answer. So we found what the measure of angle Y is. We're going to say that the measure of angle Y is 26.6. So we're going to add the 90 plus the 90 plus the 90, which I know is 270, plus 26.6. That's going to give us our final answer of 296.6 degrees. That is the direction of this vector, 296.6 degrees. All right, here's what we're going to do next. I have 2 more problems for you guys to do. Both of these problems, I'm going to ask you to try them on your own and to pause the video, and then I'm going to explain how to do them and how to get the answer after that. So here's the first problem. Go ahead and pause the video, see if you can find the direction of this vector, and then after you've given it a try, then you can watch the video to see the answer. All right, let's talk about this problem. So I drew out what the vector would look like. I went over 6 and down 5. So this is -6, -5. Now I'm going to make a little right triangle here. So this is my right angle. And this side is 6 because we went over 6. This side is 5 because we went down 5. We're trying to find the measure of this angle X right here, and then we're going to add that to 180 degrees. To find the measure of X, I'm going to say the tangent of angle X is opposite over adjacent. Opposite is 5, adjacent is 6. So the tangent of X should be 5/6. Now I'm going to do inverse tangent of both sides. So in my calculator, I'm going to take the inverse tangent of 5/6. All right, and the inverse tangent of 5 over 6 is 39.8. So we're going to add that to 180. And the final direction of this vector is 219.8 degrees. All right, let's try one more. All right, for this last problem, if we were still in the classroom, I would say, okay, Abby, choose a number between -10 and +10. And she would say, 7. And then I would say, all right, Danny, choose a number between -10 and +10. And he would say, -2. So then we would do this problem here with this vector, 7, -2. Go ahead and pause the video, try to solve this one on your own, and then you can watch the video to get the answer. All right, let's try to solve this one here. I'm going to do a little sketch of what the vector looks like. I'm going over 7 and then down 2. So I'm going to do a little right triangle here, and I went over by 7, and then I went down by 2. I'm trying to find the direction of this vector by finding this x right here. So I'm going to say the tangent of x is equal to opposite over adjacent, so 7 over 2. So in my calculator, I will take the inverse tangent of 7 over 2. And the inverse tangent of 7 over 2 is 74, we'll say 74.1 degrees. Now I have to add that to something. I have to add it to 90 plus 90 plus 90, so I'm adding it to 270. So I'm going to do 270 plus 74.1, and that is 344.1 degrees. That is the direction of this vector. And that makes sense because I know that the whole thing is going to be 360, and if I start here and go all the way around like this, I'm almost making it to 360, but just not quite. It's 344.1. All right, that is it for today. All we needed to do was find the direction of a vector, and we did that. So you guys can submit your notes on Canvas and have a wonderful rest of your day.